Hello and welcome back. This is problem F LCS from Atcoder Educational TP Contest. We are given strings S and T, and we need to find the longest string that is a subsequence of both S and T. A subsequence of a string X is the string obtained by removing 0 or more characters from X and concatenating the remaining characters without changing the order. So the subsequence is same as a subset, and the constraints for the lengths of S and T are up to 3000. Let's try to go over some of the observations for this. So since we are given two strings S and T, let's say S1, S2 all the way up to Sn, where n is length of S, and T1, T2 all the way up to Tm, where m is the length of T. Now, since we are selecting two subsequences, one from S and the second one from T, it is same as choosing two subsets, the first one from S and the second one from T. And let's say we have chosen subset this convention. I'm following this convention. Let's say S of I1, I1, S of I2, S of I3, S of I4, and so on. Similar for T of J1, T of J2, and so on. The constraint that we need to follow is that these two characters should match for all of the indices. These two characters should match, which is same as saying that the entire subsequence, the both of the subsequences are same, so that the corresponding each character at a particular index should match. So if you are selecting subset where the index from S at that particular position, so ith position is, let's say A is present and at T there is a B present, then this cannot be taken as a subsequence of equal a common subsequence. So the characters present should be same, which is same as saying that the corresponding positions as of, let's say, I1 should be equals to T of J1 for all of these subscript values, whatever the length of that subsequence may be. Now this construction has these two properties as we saw earlier. Now we need to start constructing these two subsequences, right? So we are given this S which has some fixed length, this T which has this fixed length. Now this construction is of two subsets as we saw, and these two subset can start anywhere. So the first one can start here, the first element from S could be here, the first element from T could be somewhere here, we don't know that. So first of all we need to fix what should be the starting values for this construction, and this brings us to the states of the recursion. Since we need to know at every point what are the values that we need to consider in our subset, so hence these two values should be the states of the recurrence, where I denotes the subscript for string S and J denotes the index for string T. So that means we have, let's say, ith position. We are choosing the subsequence from ith position for string S and jth position for string T. Now we are looking at these two characters at any given moment of the recurrence. So let's say go of ij is the state of the function. I am calling the function as go, which returns us the answer saying that the states of the recurrence are I and j as we defined them here. and we don't know what it computes yet. Let's look at, we just fixed the states of the recurrence right now. Now let's look at the possible choices that we have. We have string s and t. We are currently at these two positions for both of them. Now if these two values match, that means s of I is equals to t of j. That means these two can be considered in the subset, obviously, because since these characters are same, that means we can consider these two in the subset, and they are present at the same corresponding positions, because we are choosing a pair of same characters, appending them to the subsequence, not exactly appending, but saying that these two are a part of the subsequence that we are constructing, and we will move on to the next index for the subsequence. If that is the case, then the answer for this state could be 1 plus the, if we have evaluated this, we have considered both of this in the subsequence. The next choice that we can go over should be I plus 1, and the next choice for this would be j plus 1. Hence this is one of the possible way of saying that if we start constructing the subsequence at ith position for string s and jth position for string t, then if they are equal, if only if they are equal, then we can add a length 1 to the subsequence that we are constructing and compute the answer for rest of the parts of s and t, which are from index I plus 1 for string s and j plus 1 for string t. And the next choice could be that we don't want to consider ith, this was j, this was I. The next choice could be that we don't want to consider these two matching, we don't want to match them. Then the possible choice could be to move on to match I plus 1 with j, or say that this was we don't need to match this too. And the next one could be that we don't need to match I with j, then it could have been matched with j plus 1. So these two matches will give us two possible choices, the first one and the second one. And this was the initial choice that we saw earlier. It is only possible when both of the characters are same. And this will give us two possible values to evaluate the state of the recurrence, and we need to maximize them with this. Since we are not adding any character to our subsequence, we are just going over the possibilities of choices of matching them. Hence the length would not be incremented here, and we would have matched I with j plus 1 or I plus 1 with j. These are the two choices as we saw earlier, and we can maximize the answer for a particular state using these three choices. We had three choices. Now next, let's look at what we are computing over the set of subsets that we are constructing. As we saw here, we need to know what is the maximum length of the subsequence, common subsequence. Hence the value that we are computing is the length of the subsequence, and if we are at position I in string s, and if we are at position j in string t, if we match them, the length of the subsequence that we are constructing increases by 1, and the rest of the part that is available to us is I plus 1 to j plus 1, and the value that we are, the state that we are updating this is the state ij, and this one is what we are computing, which is the length of the subsequence that we are constructing. Next up, this would have been evaluated to something else, go off whatever. This would again be evaluated into some other states, and eventually we will reach at a base condition where we will find out whether there is more length that can be added to this particular subsequence or not. And eventually all of these ones or values that we are adding here would be added to find out the length of subsequence, which is the answer that we want for this problem. And hence this is the main value that we are computing, and it should be the return value of the function that we are calling here. And since we are using top-down approach, we don't need to worry about the order of violation of states. We can simply call the functions as it is, as defined in this recurrence. Let's try to formulate the recurrence in more formal manner. I am saying that go of ij denotes the maximum length subsequence if we start at ith position in S and jth position in T. These are the starting choices for this particular function. So if we only had a string, which was this part for string S and this part for string T, then in that case these were the starting positions that we were actually iterating over for finding out the a common subsequence. And we had, as we saw earlier, we had the following choices for this, and we need to maximize the answer for this state with these possible choices. The first one was to skip this, try I plus 1. So in that case there was no common element between them, hence this was this one. Next step was again skipping the j element and trying j plus 1. The next one was only possible when we are trying to match s of I with t of j, and this was only possible if the characters at those that corresponding positions are same. And these are the three possible choices, all of them, which will give us the final answer. Now let's try to understand this a bit better, how we are iterating over all the subsequence by only considering these two choices. So say we were at these two locations for I and j. Next up, if we follow this choice first, then we would have went to I plus 1. Again we would have went to I plus 2, then I plus 3, and so on. We would have ended up at the nth position. We would have tried matching I and j, then I plus 1 with j, I plus 2 with j, and so on up to all the elements in string S. And similar for string T, if we would have skipped j, then we would have taken j plus 1, then j plus 2, and so on up till index m. And we would have tried matching I with j plus 1, j, j plus 2, and m, and so on. This would have taken care of matching of all possible I with j, and hence it is uh, it is considering all the possible choices of matching between these two indices, which is what we need to do if we are considering all possible subsequences. Okay, the next thing that the question asks is to actually print the subsequence, print the actual characters in that subsequence of maximum length. So for that I've used a separate technique. I will explain it directly in the implementation part. First of all, we need to find out what is the maximum length. So I'm initializing the DP array, taking input S and T, initializing their lengths to n and m respectively, then finding out the maximum length by calling the function with states I and j equals to 0. So this function, if it arrives at a base case, that means no more matching can be done because we would have arrived at an ending position of either of the strings s and t. And if there are no more characters present here, then there cannot be any common subsequence from those positions. Hence, the answer for those conditions would be 0. We memorize the answer and check whether the state is visited. If it is visited, we will return the answer directly from there. The first choice was to check whether the characters at those locations are same. If they are same, we will consider them in the subsequence that we are constructing. And the next state from those would be I plus 1 and j plus 1. The next choice was to match up I plus 1 with j, and third was to match up j plus 1 with I. And the final answer for this state would be the maximum of c1, c2 and c3, and it would be memorized and returned from this function. This would evaluate the maximum length, but since we need to print the answer, we will use this tracing logic. Let me explain this in details. We will call the same function. The main thing that we need to do is copy the entire function, the evaluation function as it is, and separate out the choices. So we will find out, call this function as it is. We will terminate the base conditions, not go there, and we will find out what is the actual answer for this particular state. Actual answer means which is stored in dp of ij. It can be found out by calling this function, and since this could have been updated with maximum of c1, c2 and c3, we find out what value it is updated with, what ci is updated with. We need to find out that actual is updated with what value. It could be either c1, c2 or c3. If it is c1, that means this value go 1 plus go of I plus 1 j plus 1 should be equals to this value that we know, which is the answer for this particular state. If that is the case, that means this particular one corresponds to the subsequence that we were constructing, and this is the maximum length subsequence for this state. Hence, it must have been considered in the answer. And if it would have been considered in the answer, then we must print it because it is present in the longest common subsequence that we were constructing. And the rest of the answer is the same as the states of the function that were called whenever this choice was evaluated, which was I plus 1 and j plus 1. And when we will call the tracing function for those particular states. Right? Trace the remaining part. If the second choice was the answer, that means actual, which was maximum of c1, c2 and c3, was actually c2. In that case, we ignored or we neglected the value. We did not, this was actually 0 plus that. That means there was no common element between them and we skipped it. That means we don't need to print, or there was nothing considered in our answer, but we need to trace the remaining part from this particular portion of states, which was I plus 1 to j, which is same as the states of this choice. So these choice states will remain same for the entire tracing function. So I to j plus 1 to j plus 1 similar. So this two look identical, and they are because there are no common element in the subsequence that we are constructing, hence we are not printing anything here. Here we were printing because we were considering that subsequence in our answer and we need to print the answer from there. This is the main logic. So if I had to summarize this, you need to first of all clone the main recurrence function as it is, separate out the terms for each of the choices c1, c2 and c3, convert the base condition to return from a base condition. Then you need to find out what was the actual answer for this particular state and find that particular answer considering all the choices, and all the choices are the same as they were present in this main evaluation function. So you just check whether actual answer is c1, c2 or c3, and depending on that you move on to the next state, which would be the same as the state of that choice. So these tracing states and the choice states are as it is. Just check whether according to any problem that we are going to solve, just check whether we need to print the answer there or not, and evaluate the tracing function from the remaining states. Yep, that's it about this. This will give us the final answer, and the time complexity for this would be order n times m, because since this is the main part and we are memorizing this, there are order m possible choices for this and order m for this. The transitions are constant time, which is 3, and hence the overall time complexity would be order nm. The time complexity for this should be order of maximum of n plus m. Not maximum of n plus m, but maximum between n and m, because the length of the maximum common subsequence would be, no, it could only be minimum of them, right? Because if we have 3 elements in S and 6 elements in T, then the length of the maximum common subsequent can only be 3. Hence it is minimum of length of S and length of T. The time complexity for tracing. So tracing will only visit the states which is equal to the maximum length subsequence, since it is printing the answer wherever it is possible and going only over the states where the maximum answer is produced. Hence this would be evaluated in order length of the subsequence time. That's it about this video. If you found this helpful, or if you have any doubts or suggestions, do let me know in the comments. Thank you.